In this section, we have trigonometric substitution. Here on this part, we have procedure for the trigonometric substitution. Step 1, write down substitution for x, calculate the differential dx, specify the selected values of theta for the substitution. So this is our first step. Then second step, substitute the trigonometric expression and the calculated differential into the integrand, and then simplify the results algebraically. Step 3, integrate the trigonometric integral, keeping in mind the restrictions on the angle theta for reversibility. Step 4, draw an appropriate reference triangle to reverse the substitution in the integration result and convert it back to the original variable x. So here on this part we have right triangles. The one that I have here on left side. So here our angle is theta, and we have this side as a, this side is x, and we have hypotenuse is the square root of a squared plus x squared. When we have this, we're going to use x equal to a times tangent theta, and our square root of a squared plus x squared, that is equal to a times absolute value of secant theta. Then this one that we have here, hypotenuse is a, this side is x, and this side is square root of a squared minus x squared. So in this case, we're going to use x equal to a times sine theta. And square root of a squared minus x squared is equal to a times absolute value of cosine theta. And the last one that we have here on the right side, hypotenuse, so this side, this part, hypotenuse is x. This side is square root of x squared minus a squared, and this side is a. When we have this right triangle, we're going to have x equal to a times secant theta. In this case, square root of x squared minus a squared, that is equal to a times absolute value of tangent theta. So these are reference triangles for the three basic substitutions. I find the sides labeled x and a for each substitution. Example 1, evaluate integral. Here we have negative 2 times square root of 3 to positive 2 square root of 3, and this is for dx divided by 4 plus x squared. So on this part, based on what we have in denominator, 4 plus x squared, this is the same as the right triangle that we had. Hypotenuse was square root of a squared plus x squared. In that case, x is equal to a times tangent theta. What is given is 4 plus x squared, so that is equal to 2 squared plus x squared. So what I have here, this one is a, so a is equal to 2. So this means we're going to use substitution x equal to a times tangent, and a is 2 because of what I have here. So x is equal to 2 times tangent theta. So in this part we have x squared. Use x equal to 2 times tangent theta and find x squared. So x squared is equal to 4 times tangent squared. And then we have to find the derivative of what we have here for x. Recall that derivative of tangent with respect to theta, that is equal to secant squared theta times theta prime. So based on that, dx is equal to 2 times, so derivative of tangent is secant squared theta times d theta. Note that when we have x equal to 2 times square root of 3, theta is equal to pi over 3, because here we have 2 times square root of 3 equal to 2 times tangent theta, and based on that, tangent theta is equal to 2 times square root of 3 divided by 2. So tangent theta equal to square root of 3. When tangent theta is equal to square root of 3, that is when theta is pi over 3, because tangent pi over 3 is equal to square root of 3. And here we have negative 2 times square root of 3 equal to 2 times tangent theta. So when we have x equal to negative 2 times square root of 3, theta is negative pi over 3. And that is because tangent negative pi over 3 is equal to negative square root of 3. So based on that, theta is negative pi over 3. So this means when we try to integrate dx over 4 plus x squared, and this is from negative 2 square root of 3 to positive 2 square root of 3, that is equal to, now instead of x here we have theta. So what we have for dx is 2 times secant square theta d theta on top in numerator, so on this part. And in denominator we have 4 plus x squared, and x squared is equal to 4 tangent squared. And in this case, instead of negative 2 square root of 3 and positive 2 square root of 3, now we have to use what we have for theta. And for theta we have negative pi over 3 and we have pi over 3. So next step here on this part, we have to integrate 2 times secant squared theta d theta divided by I factor out 4. So in denominator we have 4 times 1 plus tangent squared, and then simplify. What we have here is 2 divided by 4, so that is 1 over 2, and I have that outside of integral. So next step is equal to 1 over 2 times integral secant squared d theta divided by 1 plus tangent squared. And then instead of what we have here in denominator 1 plus tangent squared, that is equal to secant squared. So here rewriting all these, but here in denominator we have secant squared. Then next step here on this part, what I did is that I can cancel this part, secant squared divided by secant squared, so that part is 1 times what is left here is d theta. So here we have d theta. So here we have 1 over 2 integrate d theta. So that is equal to 1 over 2 times theta, and this is from negative pi over 3 to pi over 3. So that is equal to 1 over 2 times, using this part first instead of theta, so we have pi over 3 minus, use this instead of theta, negative pi over 3. So this part is 2 times pi over 3 multiplied by 1 over 2, cancel that part, the answer is pi over 3. So this is our final answer for this part. Evaluate the integral, integrate square root of 100 minus t squared times dt. So in this case we have square root of 100 minus t squared, and we're going to use what we had for this part, square root of a squared minus x squared. So in that case x is equal to 8 times sine theta. So based on this, what we have here on this part for a, this is 100, so that is 10 squared. So 10 squared minus t squared. So that means our a is 10, and instead of x we have t. So use the substitution t equal to 10 times sine theta. So using t, now we have to find dt, so derivative, that is equal to 10 times cosine theta d theta. And now find integral. This is equal to integral square root of 100 minus, instead of t, here I'm using 10 sine theta. So t squared is equal to 100 sine squared. And then here on this part, multiply by dt, and that is equal to 10 cosine theta d theta. And then next step, here factor out 100. So 100 times 1 minus sine squared, that is inside square root, and then multiply by 10 cosine theta d theta. So square root of 100 is 10, multiplied by square root of 1 minus sine squared times 10 cosine theta d theta, and then multiply these two. So we have 10 times 10 is 100. I move that outside of integral. So we have 100 times integral square root of 1 minus sine squared times cosine times d theta. Instead of 1 minus sine squared, I used cosine squared. So what we have here is equal to 100 integral square root of cosine squared times cosine times d theta. Next step, use the fact that cosine theta is greater than 0 when theta is between negative pi over 2 and pi over 2. So use this to simplify. So what we have here on this part, this is equal to 100 integral instead of square root of cosine square. Now here we have absolute value of cosine multiplied by cosine times d theta. And then next step, so cosine theta is greater than 0 because of that. Instead of this part, now we have cosine times cosine is equal to cosine squared. And then we have to use the double angle identity to remove powers of cosine theta. So instead of cosine squared, I used 1 plus cosine 2 theta divided by 2. And then I simplified this part, so 100 divided by 2 is 50, multiplied by integral 1 times d theta, then plus, again, 100 divided by 2 is 50 times integral cosine 2 theta times d theta. Now integrate, so we have 50 times theta plus 50 divided by 2 times sine 2 theta plus c. So c is constant. Then next step, I simplified 50 divided by 2. Here we have 25. And then I use double angle identity sine 2 theta equal to 2 sine theta cosine theta to get an expression in terms of sine theta and cosine theta. So instead of this part that we have here, sine 2 theta, I use 2 sine theta cosine theta. So this is equal to 50 theta plus 25 times 2 times sine theta cosine theta plus constant. So here 25 times 2 is equal to 50. So here we have 50 theta plus 50 sine theta cosine theta plus c. And then using what we have here, so we had t equal to 10 sine theta. I use that one to find theta. So sine theta is equal to t over 10. Based on what we have here on this part, theta is equal to inverse sine t over 10. So use that here on this part. Instead of theta, we have inverse sine t over 10 plus 50 times sine theta is what we have here, t over 10. And now here we have cosine. So finding cosine, use sine squared plus cosine squared equal to 1 to express cosine in terms of t. So I used sine squared plus cosine squared equal to 1. Cosine squared is equal to 1 minus sine squared. So cosine theta is equal to square root of 1 minus sine squared. And sine is t over 10. So cosine is equal to square root of 1 minus t squared divided by 10 squared. So we have here inside, we have 1 minus t squared divided by 100. And then simplify that part. So we have 100 minus t squared divided by 100. This is inside square root. And then cosine is equal to square root of 100 minus t squared divided by, here in denominator, we have 100. So finding square root of 100 is equal to 10. So I use 10 in denominator. So I will use this one, this cosine, here on this part. So instead of cosine, we have square root of 100 minus t squared divided by 10. And then simplify that part. So this is equal to 50 times inverse sine t over 10 plus, so here we have 10 times 10, that is 100 in denominator. On top we have 50. So 50 divided by 100, so we're going to have 1 over 2 times t. That's how I got t over 2. Multiply square root of 100 minus t squared plus c. So this is our answer for this part. Evaluate the integral dx over x squared times square root of x squared minus 9, where x is greater than 3. So in this case, we have to use the substitution x equal to 3 times secant theta. Here we have x squared, so finding x squared based on what x squared is equal to 9 secant squared. And find the derivative of x, so dx is equal to 3 times secant theta times tangent theta times d theta. So integral is equal to, instead of dx, I use 3 secant theta tangent theta multiplied by d theta. This is what we have here on top in numerator, and denominator x squared is 9 secant squared times square root of x squared is again 9 secant squared minus 9. The next step, what I did here on this part, here we have 9, here we have 9, so factor of 9, and then square root of 9 is 3. So this is what they have here on this part. We have 3 times square root of secant squared minus 1 for that part. Then multiply by 9 secant squared in denominator, and rewriting what we have here on top. So this is equal to, we can simplify, so 3 divided by 3, and what's left here we have 1 over 9. I move this 1 over 9 outside of integral, and we can cancel secant, and here in denominator we have secant squared. So what's left here in denominator is secant times square root of secant squared minus 1, and on top we have tangent theta multiplied by d theta. And that is equal to 1 over 9 integral tangent theta d theta, denominator secant theta times, instead of secant squared minus 1, we have tangent squared. Then square root of tangent squared is equal to tangent, and secant is equal to 1 over cosine. And that is equal to, we can cancel tangent. And here we have 1 divided by 1 over cosine, so that is equal to cosine. So we have 1 over 9 integral cosine theta d theta. Integrate, so this is equal to 1 over 9. Integrate cosine, that is sine theta plus constant. So what we had for x, that was equal to 3 times secant theta. Then based on what we have here, secant theta is equal to x over 3, and cosine theta is equal to 3 over x, because secant is 1 over cosine. So secant is 1 over cosine, that means cosine is 3 over x. I used secant squared plus cosine squared equal to 1, and based on that we can find sine, because here we have sine. I'm trying to find what we have to use instead of sine for that part. So sine is equal to square root of 1 minus cosine squared, and that is equal to square root of 1 minus cosine is 3 over x. So 3 over x, square that part, we're going to have 9 over x squared. And then simplify this part, so we have denominator is x squared, and on top we're going to have x squared minus 9. So this is equal to square root of x squared minus 9 divided by x squared, and we can simplify this part, so square root of x squared, so what I have here in denominator, that will be equal to x. So the final answer is equal to 1 over 9 times sine theta. So 1 over 9, here I have 1, here I have 9, and sine theta is what we have here on this part. We can simplify, so that is square root of x squared minus 9 divided by x, and then multiply by 1 over 9. So this is how I got this part, and then plus our constant. So this is our final answer. Final answer is equal to square root of x squared minus 9 divided by 9x plus c. Evaluate integral from 0 to 5 square root of 3 divided by 2. Here we have 5x squared dx divided by 25 minus x squared, power is 3 over 2. So in this case, based on what we have here on this part, 25 minus x squared, I used the substitution x equal to 5 sine theta. Here we have x squared, so finding x squared based on what x squared is equal to 25 sine squared, and we have to find dx. So dx is equal to 5 cosine theta d theta. So based on what we have here on this part, 0 and 5 square root of 3 over 2. Theta is 0 when x is equal to 0, and theta is equal to pi over 3 when x is 5 square root of 3 over 2. So here I have all steps, how I have theta equal to 0 and theta equal to pi over 3. So on this part I used x equal to 0 based on that, or theta is 0, and this part when x is equal to 5 sine theta, and sine theta is equal to x over 5. So sine theta is equal to over x is 5 square root of 3 over 2 divided by 5. Then simplify, sine theta is equal to square root of 3 over 2, and in this case theta is equal to pi over 3. So when theta is pi over 3, sine pi over 3 is equal to square root of 3 over 2. So our integral is equal to 5 times integral from 0 to pi over 3 for theta, and in numerator on top we have 5 times x squared is 25 sine squared times dx is 5 cosine d theta. In denominator we have 25 minus x squared is 25 sine squared, and our power is 3 over 2. So that is equal to, here I multiply 25 times 5, so that is 125 times sine squared times cosine times d theta. And denominator, so rewriting this part, 25 minus 25 sine squared power 3 over 2. Then this is equal to, in denominator I factor out 25, so 25 power is 3 over 2, multiplied by 1 minus sine squared power 3 over 2. Then this part 25 power 3 over 2, that is equal to 125, and instead of 1 minus sine squared I use cosine squared. Then next step here, simplify, so 125 divided by 125, and then on top we have cosine, denominator we have cosine squared power 3 over 2. So this part is cosine cube, because here we have cosine square power 3 over 2, so that will be equal to cosine cube. And on top we have sine square times cosine theta times d theta. Then that is equal to, here we can cancel this part, cosine divided by cosine cube, we're going to have 1 over cosine squared. On top we have this one, so sine squared times 1 times d theta, and denominator cosine squared. So what we have here, we have sine squared divided by cosine squared, that is equal to tangent squared. Instead of tangent square I can use secant square minus 1. So here we have 5 times integral from 0 to pi over 3 secant square minus 1 times d theta. So integrate this part. For this part secant square d theta, we have tangent theta, and here on this part we have 1 times d theta, so integrate that part, that will be minus theta. And then multiply by 5, and this is from 0 to pi over 3. So use pi over 3 instead of theta, and use 0 instead of theta. So using 0 for theta, that will be 0, so tangent 0 minus 0, that is equal to 0. So I didn't write that part because it is 0. But writing pi over 3, so we're gonna have 5 times tangent pi over 3 minus pi over 3, and then minus 5 times tangent 0 minus 0. Again, that is 0, that's why I didn't write that part. But instead, I only have this part, 5 times tangent pi over 3 minus pi over 3. Tangent pi over 3 is equal to square root of 3, so this is our final answer, 5 times square root of 3 minus pi over 3.